So let me think about the displacement of the ball from its rest position. Let's say that's the rest position, and I'm going to think of the displacement as x. So as the ball goes up and down, I'll let the displacement be given by x, and so when x is 0, it's at its rest position. So let's say at time t, when time t is equal to 0, the ball is here. So at this time, the ball is just passes the rest position and is on its way up. So it goes up, down, up, down, up, down. Now, we know we've already seen that the displacement of the ball and the acceleration a is related by this formula. A is equal to minus omega squared x. And what I like to do now is to understand, right? Is to understand why this equation means that x, why this equation implies that x must have such a form that it is a constant times sine omega t. Okay, to be precise, there's actually another form that would also. There are actually other forms that will also work. I might talk about those later. So this is just one possible formula for x. Okay, one possible formula for x that will, if you like, satisfy this equation. That will make this equation true. Okay, this is a formula for x for which the acceleration of the ball as it goes up and down is related to x by this equation. So I want to understand why this jump from this equation, which doesn't have a sine or cosine function, to x is equal to something with even a time variable inside. So this does look like a very big jump. Now there are actually two ways to understand this. One way is mathematical, the other way is physical. Now the mathematical method it involves a type of mathematics called differential equations, which is quite a bit complicated to talk about here. So I shan't go into that. I am just going to talk about the physical method here, which is also useful because this will show how the simple harmonic motion is connected to circular motion. Right. So let me start by thinking about a circular motion. So let's say this is the x and the y-axis. Now, because I'm using x for this vertical displacement, I'm just going to exchange the usual x and y symbols. I'll call the vertical axis x and I call the horizontal axis y this time for a change. Okay, so that the x here has the same direction as the x here. Now next, let me think about a ball. Let me think about a ball on this graph. Okay, and imagine that this ball goes round in a circle, around the origin. Okay, so what has this got to do with simple harmonic motion. Okay, right, so bear with me. Now, as this ball moves up and down, okay, let's say at a certain time, this ball comes here. Let's say at a certain time, this ball comes here. Okay. Now, let's say this is at the same value of x as this ball goes around the circle. So my x equal to 0 is here. X equal to 0 is at the same level as this. Okay. Now, can you now think about this situation? Suppose that as this ball goes round and round the circle, as this ball goes round and round in this circle, this ball on the spring goes up and down. Okay. Now, is it possible that the x value of this ball, the vertical displacement of this ball, is always the same as this? In other words, the height of the two balls go up and down together, and they always have the same x. Is that possible? So when this ball goes up there, okay, when this ball goes up there, this ball goes up here. When this ball comes down here, that ball comes down to here. When this ball comes down to here, this ball comes down to here. So always keeping the same level. Now I'm making a guess here. I'm making a suggestion. I'm not saying that they must be like that yet. I'm just saying, is it possible? Can it happen that when this ball goes round and round, the up and down motion of the ball, the change in the x value of this ball, is it possible that the x of this ball follows exactly the x displacements of that ball? Because if it is possible, all right, then we have a very interesting connection. Now, but how are we going to find out? How are we going to find out? Right, the way to find out is this. The way to find out is to look at, what I can do is I can look at this graph. Okay, I can try and find the connection between the x value of this ball, in this case the vertical coordinates, and the acceleration of this ball in the x direction. Now, if in this circular motion case, if I can show that for this case the x motion value of the ball and the acceleration along the x direction are related by this same formula, then I will know that the x value, the vertical displacement of this ball, can indeed follow exactly the x displacement of that ball. Okay, because I know that this ball obeys this equation. Okay, if I can show that the x value and the x acceleration of this ball also obey the same equation, then I would know that the height of this ball would always be exactly the same as the height of this ball. So both of them will go up and down together, always keeping the same